All right, so starting this review, we are trying to write the point slope form and the slope intercept form equations if possible for each line. If possible is because if we have a vertical line, x equals a number, then you can't write point slope or slope intercept form, but anything else should work. So I have a point. I can use either one of those points, but I need a slope to write the equation of a line. So we've got to subtract the y values in any order. So I'm going to go 4/9 minus 2/3. That means that I then need to subtract my x's in the same order. 1/3 minus 5/6. Get common denominators. 2/3 gets multiplied by 3/3, so that becomes 6/9. Common denominator down here, 1/3 becomes 2/6 minus 5/6. 4 minus 6 is negative 2/9 over negative 3/6. That becomes negative 2/9 times, now this is negative 1/2, so the reciprocal of that will be negative 2/1. Okay, and then finally, the slope ends up being positive 4/9. And we need to write the equation, point slope equation in the slope intercept form. So start with point slope form. That's y minus, pick any, it doesn't really matter here, pick any one. Y minus y1, I'm just going to go with the first point, equals the slope over x minus x1. So this is point slope form. That's finished. If I want to get slope intercept form, this will be a little bit of a chore, but we take point slope form and start solving for y. So I would distribute 4/9 through. So y minus 4/9 equals 4/9 x minus, this becomes 4/27. The last step will be to add 4/9 over. So I've got negative 4/27. And then if we're adding 4/9, we're really adding 12/27 to get that common denominator. So y equals 4/9 x plus 8/27. Right? So we should be able to check these. These two equations should be the same line, and these 2 points should be on that line. Number 2 is a line that passes through negative 2, 4 and is perpendicular. Remember, that means the slope is an opposite reciprocal to this line. So the first thing to do is see what slope you're working with. So solve for y. Excuse me. So the slope that I need to work with to make a line that's perpendicular to this line is negative 2/3, the opposite sign in the reciprocal. And start with point slope form. Y minus 4 equals negative 2/3 times x minus negative 2, x plus 2. So there's point slope form. And slope intercept form is to begin solving this for y. So distribute negative 2/3 through and add 4. Negative 2/3 x minus 4/3. When you add 4, put it over a denominator of 3, so you're adding 12/3. And let's put this down here. So y equals negative 2/3 x plus 8/3 is my final answer. This is for number 2. I'm just going to section this off here. Okay, what about passes through these 2 points? So again, we can do a slope. y2 minus y1 over x2 minus x1, subtract in any order. You get 0 over negative 10, which is 0. So if the slope is equal to 0, you could write a point slope form equation. Y minus 12 equals 0 times x minus 9. You could write that. Or you could just write y equals 12. If you plot these 2 points, the y coordinate is 12. Or if you solve this for y, because you're distributing 0 through, you're going to get y equals 12. If this were on our quiz, do you need to write the point slope form equation with the 0? Only if I have a separate blank for it. Like I'll have 2 blanks or 1 blank or something. So if you're not sure, just write it. Like if you're asking the question, you know how to do it. So just write it down, basically. Okay. Number 4 has a y-intercept of 5 and is perpendicular to the line x equals 3. Y-intercept of 5 means that we have the point 0, 5. Perpendicular to the line x equals 3. So remember that as a vertical line. So perpendicular to a vertical line just means we're supposed to have a horizontal line. Horizontal line is always y equals, and in this case, it's going to be y equals 5 for that value. Again, if I had to go and write the point slope form, I could say y minus 5 equals 0 times x minus 0. But for this one, I'll just do that. Okay, switching gears, determine whether or not each relation is a function. So we're going to say function or not function. Justify your answer. So this is AP style. I talked about this in the notes on Tuesday. That even though we can be thinking about a vertical line test in our head or using that on our paper to kind of help us decide, it can't be our justification if we're answering on the AP test. So, and honestly, these are mostly not graphing problems. So, so let's think about our rules. Remember, you can solve these for y if you need to. I'm going to solve the first one for y. In our notes, we made a table of points to decide what was happening, but now that we've done this a bit, remember when you cube root an equation on both sides, it does not generate a plus or minus. So whatever you plug in for x, you are just going to get one answer for y. And the other rule we had was that if y is raised to an odd power, that means this thing is a function. Assuming we have nothing else going on, like an absolute value, which we'll talk about in a minute. So this is a function. And if I have to justify, your justification is kind of a script. We're going to say one of 2 things. In this case, I'm just going to say each input has exactly 1 output. If my answer is that something is not a function, my justification will be some inputs have, or either each or some inputs have multiple outputs. Okay. Absolute value of 2x minus 1. This is one where maybe in my head I'm thinking about a graph, and you don't have to be too specific. Just remember what an absolute value graph looks like. This one's been stretched and shifted a little bit, but it's a V shape, right, of some sort that opens up. A V shape does pass the vertical line test, so I'm allowed to think about all of this. I'm allowed to draw this on my paper. The AP grader will ignore all of this, though. And so if you're going to answer, again, you're going to say this is a function because each input has exactly 1 output. And I know that's going to get tedious to write that over and over, but I kind of think if you have to write it over and over, maybe you won't forget to do it. Okay, number 7. This time we have 2x squared minus 3y squared equals 12. All right, so thinking about this, what did we say on number 5? When y is to an odd power, we have a function. When y is to an even power, that's going to be not a function. And that's because if you're solving for y, you're going to get that y equals plus or minus the square root of something. So whether or not you actually solve for y here, you don't really have to, not for our Friday quiz. You can say not a function. And I'm just going to change this a little bit. Each input has I'll say 2 outputs. Every time you plug in an X, you're going to get a plus or minus Y of some sort. Okay. Or maybe you might, if you wanted to go further, you could say each input has 2 outputs. Actually, I'm not going to say this. I don't think you would have to, but it's because of that plus or minus. Okay, what about number 8? So what about the absolute value around the Y? I don't think I assigned this in homework, but I know that I talked with some of you about it because I did assign one of the absolute value around the X's. So an absolute value Y graph opens to the right or sometimes left, depending. But just think about this. Plug in, if you plug in 5 for X, I'll just give you an example of this. So when does absolute value Y equal 3? When X is 5, when I plugged in 5, there are 2 values for Y that would satisfy this. Y could be 3 or Y could be negative 3. Right? So when X is 5, Y could be 3, Y could be negative 3. And because that happens, it forms this little sideways V shape. So you don't have to justify it with all of this. You can just say, if I have an absolute value around a Y, it's a V opening sideways somehow, which fails the vertical line test. That just can't be my official justification. So in my head, I've convinced myself with vertical line test, but on my paper, I'm going to write, not function. And I'm going to say the same thing I said for 7. Each input, or I guess this vertex input wouldn't, so maybe I'll say some inputs have 2 outputs. If you're not sure, is it every input or is it just some of them? I think some is probably the safe option. I'm not going to be picky about that on our quiz, but I'm just kind of trying to anticipate what some of our AP graders might do. Okay, on number 9, remember when Y is squared and we are the ones introducing the square root as we solve for Y, that's where a plus or minus is generated. This number 9 is just saying Y is equal to just the negative square root of X plus 4. If you want to think about a graph, we're going to do this in, I don't know, a few days, I guess. This graph kind of looks like that. That does pass the vertical line test. But again, even if you're not remembering the graphing rules, start plugging in some X's. You will find that you just get one Y value. So this is a function because each input has exactly one output. Well, what about something rational? Y equals 1 over X plus 2. Well, one hint that this is a function is we had problems like this all over the domain and range packet, which those were all f of x. But also just start plugging things in for x and realize there's no way to get like a plus or minus. So once you've convinced yourself of this one too is a function. Each input has exactly one output. Okay? So again, I might have drawn vertical line test. At no point did I write that out as my answer. On my quiz tomorrow, if I give you a question like this, I will make sure I'll have the same instructions. Do not give the vertical line test as your justification. Okay, moving on. Use the graph to answer the questions below. On your paper, you should have the points labeled A, B, C, D, and E. Those are either x-intercepts, relative extrema, or points of inflection. I didn't specify which was which because that's the first question. So list the points by letters. We're just going to use A, B, C, D, or E that fall into each category. So which ones are x-intercepts? That's where you're crossing the x-axis. So those are points A, C, and E. That's where we're on the x-axis. Relative maximum, remember this is where the graph changes from increasing to decreasing. So it looks like point B is a relative maximum. And that's it. Relative minimum, where the graph changes from decreasing to increasing. That's got to be point D down here. Points of inflection. Remember, this is where we have a change in concavity. What's concavity? We talked about this on Wednesday. Concavity is the curvature where the graph changes from concave down, in this case, to concave up. So again, we were told that these points include a point of inflection. So I can see that the graph is concave down for a while, and then at some point in here, it switches to concave up. So it's got to be point C. Identify the intervals on which the function is increasing, decreasing, constant. This doesn't say to use the letters, but at point B, for example, I don't have what that exact value is for you, so we're still using letters for this. Okay, so with that said, just note if we have actual numbers, we will use X values if given numbers, whatever. If the numbers are easier to look at, these were, I typed in a strange function into Desmos. Okay, so where is this graph increasing? Let's start there. Remember, you follow the graph left to right. So this graph is increasing. Didn't mean to erase my points there. From the far left up to point B. So that's negative infinity. I'm just going to say to B. Use parentheses always for these. These turning points are not considered increasing or decreasing. And then the graph decreases for a while. And then it looks like after point D, it starts increasing again without bound. So I'm going to say with parentheses, D to infinity. Again, if we could see that D was at like 3 or something, then we would say 3 to infinity. Or if B was at -1 to infinity. Okay, then there's also a decreasing section. The decreasing section is in the middle here between B and D. So I'm just going to say with parentheses, B to D. And there is no constant section. On the quiz tomorrow, if I give you, I'll have blanks for this so that it's easy for me to find your answers and grade them. So if there's a blank for any one of the sections and it doesn't exist, don't leave it blank. Write no solution or NA or put a slash through it, something so that I know you didn't just skip the problem. On the interval -2 to 4, so that is A to E, just on this middle interval here, ignoring the outer parts. Gosh, I keep erasing that. Okay, on the interval -2 to 4, name the points, if any, that represent the absolute maximum and absolute minimum. If I give you a closed interval like this that has endpoints and f is continuous, which it is, this graph is continuous on that interval, there has to be an absolute max and an absolute min. Okay, so take a look on here. What is the actual highest point on the graph? Looks like it's point B. So the absolute max is going to be point B, and the absolute minimum is down here at point D. If I change the question slightly on the interval all real numbers, so extending beyond A and E, name the points, if any, that represent the absolute maximum and absolute minimum. If this graph goes on forever without bound, which it does, we can assume that it does, there is no ceiling or floor to this. There is no absolute high point. You pick a high point, I can find one higher. Same with low points. So you can't have an open interval like this for all real numbers. There are no absolute extrema on -infinity to infinity. If I said on -1 million to +1 million, those endpoints would be the absolute max and min, because I know they're much higher and lower than these relative extrema. So yeah, it's got to be a closed interval. Determine the intervals for which the function is concave up and the intervals for which the function is concave down. Also state whether the rates of change, the slopes, are increasing, decreasing, or decreasing on those intervals. Okay, remember, concave up looks like a smile or a bull. Concave down looks like a frown. Right? So if we look at this graph looks like it's frowning, concave down, far left until we hit C, and then it looks like it's concave up from C to infinity. So let's start there. Concave down on the interval negative infinity to, let's just say, point C. The turning point, the point of inflection, is not included in concavity. And then let's say concave up on C to infinity. Okay. On each of those intervals, we're supposed to say, is the rate of change increasing or decreasing? So take a look back in your notes packet if you're not sure on this one. I don't even have to look at the graph to answer this question. I will in a minute, but I'm going to answer the question first. We have in the concavity box in our notes, it says f of x is concave down if the rates of change are decreasing. Okay, so that has to be true. I'll double check that and I'll explain what that's talking about again, but I'm just going to get the correct answer first. Okay, so this is something just to study too. We tell our calc kids this too. It's just, this is something to have memorized and to not overthink. I want you to understand it, but I also don't want you to get it wrong. It's kind of an easy pairing. Okay, so concave up means that, again, check the box in your notes, the concavity box. The rates of change, in other words, the slopes, are increasing if a graph is concave up. Let's just double check that. Concave down, are these slopes decreasing? Let's see. Super positive slope, still positive, less steep, still positive, less steep, still positive, less steep, gets to 0. Are those slopes decreasing? Yeah, I can make up some numbers here like I did in the notes. Maybe that's a slope of -8. Maybe the slope starts shallowing out. Oh, not -8, sorry. Maybe that's a slope of 8. Maybe that's a slope of 2. Maybe this is a slope of 0. Are those numbers going down? Yes, those slopes are decreasing. And even when we said the concave down goes all the way to C. These are negative slopes, right? Maybe this one's -1. The negative slopes, it's hard to tell on this shallow interval, but they are getting steeper. Maybe this is -1.5 or something. Okay, so these negative numbers are also decreasing. They're getting more negative. So that's what we mean by the rates are decreasing on that interval. Are these slopes increasing on concave up? Yeah, because at C, this is the point of inflection. So the slopes are negative, but they're starting to get closer to 0 again, right? And if you're going from -1 to maybe -1/2 to maybe 0, those numbers are increasing. And then they get more and more positive as we go. So I would love for you to be able to picture this and keep this in mind and understand exactly what I mean by slopes are increasing and decreasing. But I also would love for you just to have this relationship memorized because they're going to ask us this. And this can be easy points, even if we're a little bit iffy on the picture of it. Concave down, rates are decreasing. Concave up, rates are increasing. These next questions are kind of like I kind of drew inspiration from the AP Classroom problems. So on which intervals are the rates of change positive and increasing? Let's break that into two things. I'm going to say slopes instead of rates of change. Slopes, positive. Think about what that means. Draw a positive slope. Your positive slope represents a function right now. Is that function increasing or decreasing? That function, f, is increasing if its rates of change are positive. So we're looking for a part of the graph that's increasing. And the slopes are increasing, it says. Not only are the slopes positive, but they're increasing. Remember, slopes increasing equates to concave up. F is concave up. Go find the section on the graph that is increasing and concave up. Increasing and concave up, right there, from D to infinity. Okay, let's do the same thing for the next one. Now, where are the rates of change positive? Okay, that means F is increasing. And where are the rates of change decreasing? Rates of change decreasing means concave down. So we are looking for the section of our graph where the graph is increasing and concave down. That looks something like this, right? Go check. Increasing, concave down. Right there, from negative infinity up to B. On which interval are the rates of change negative and increasing? When are the slopes negative? Draw a negative slope. If I just say that little slope is F, what is F doing? F is decreasing. So when I say the rate is negative, what I mean is F is decreasing. And when are the slopes increasing? That's, remember, back to this relationship. When the slopes are increasing, the graph is concave up. Find a section that's decreasing and concave up. Here's decreasing. Well, B to D is decreasing, but it's kind of hard. I've got so many marks all over this. Hold on, get rid of some of this. This is the concave up section, right? So this is just going to be C to D. Okay, you can probably guess the next one's B to C, but let's just kind of verify through here. So the rates are negative. That means F is decreasing. And the rates are decreasing, which means F is concave down. A decreasing function that is concave down. That is B to C. Okay? All right, so B to C. Concavity is new. I know that you talked about increasing, decreasing, constant, but I know that we do not compare them to rates of change in Algebra 2. That's a pre-calc thing. So it's okay if this is a little foggy. The thing to study is your concavity box and this relationship right here. Okay. What about finding average rate of change? So average rate of change, remember we have a formula for that on the given closed interval. So what this means is I want the slope, I want the average rate of change, I want the slope between the x values -3 and 8. If you're given a table, your work is pretty easy. Write the formula, f of 8 minus f of -3 over 8 minus -3. Even my calculus kids have to write this formula because you get a point for it, usually. Okay, f of 8 is 5 minus f of -3, 20. 8 plus 3 is 11. So the average rate of change is -15/11. Okay, what if I give you a graph? So I've listed out the 2 points just so you have them specifically. I want the average rate of change on this interval here from -3 to 0. So remember what we're saying, average rate of change, just saying, what is the slope of that line that I just drew? F of 0 minus f of -3 over 0 minus -3. F of 0 is -2.5. F of -3 is 2. 0 minus -3 is +3. Okay, now what is this? -4.5 over 3. We are not going to leave our answer like that. we're going to get ourselves out of these mixed numbers. What's negative 4.5 as an improper fraction? 4 times 2 plus 1. It's negative 9 over 2. Negative 9 over 2 divided by 3 is negative 9 over 2 times 1/3. 9 over 3 reduces. It's negative 3 over 2. Definitely simplify. Decimals and fractions are not considered simplified. Okay, last one here. I gave you a table, gave you a graph. I'll give you a function here. Same thing. Rate of change is f of 1 minus f of negative 2 over 1 minus negative 2. F of 1, let's see. So that's going to be, if I plug 1 into this, I get negative 1 plus 1/2 minus parentheses, so I don't forget to change signs if needed. If I plug in negative 2, now cubing negative 2 is negative 8, but then there's a minus sign in front, so you get positive 8. And then we plugged in negative 2, so plus 1/2 times negative 2 is minus 1, all over 1 plus 2, which is 3. This is negative 1/2 minus 7 over 3. It's negative 1/2 minus 14 over 2, negative 15 over 2. Instead of divided by 3 times 1/3, instead of going 15 over 6, you can reduce 5 over 1, negative 5 over 2. If my fraction work is kind of confusing you or you're getting lost in all of that, I know I am going quickly, but if you ever want to practice with fractions like this, these are easy to make up in office hours or during flex. We are expected to do all of this without a calculator. Just for me, I expect that from you. For the AP test, they expect that from you, and beyond. Okay, domain and range. You have a big domain and range packet. Some of those problems are harder than what I would have on our first quiz because we haven't done all of the types of inequalities that I gave you in the packet. Okay, why did I give those to you? Because I do know that you did them last year. So might as well practice for homework. But here's what's fair game for the quiz. Domain, range. Use interval notation. First one here. This is a square root function, so x plus 6 needs to remain greater than or equal to 0, x greater than or equal to negative 6, so the domain is negative 6 to infinity. For a range, this is a square root function, and it's just a line underneath the square root function, right? You could also think like plug in negative 6, you get 0. Plug in negative 5, you get square root of 1. Plug in negative 4, you get, if you keep plugging in numbers, you're going to keep getting higher and higher numbers. Or you could think of the graph. Lots of ways to get the range on this one. But the square root of a linear expression will always be 0 to infinity, unless I put like a negative sign out in front or something like that. What if I change the function for 24? So now it's 1 over square root of x plus 6. What does that change for domain? It means that the domain is now x plus 6 can only be greater than 0, not greater than or equal to, because now you don't want to divide by 0. X has to stay greater than negative 6. So negative 6 to infinity without including negative 6. What about the range? Now that this is 1 over the square root, the graph is too hard to picture. This is where I run through the checklist. It's 1 over the square root of something. Think about how that comes out. First of all, y can't equal 0 because there's no x up there. No x you can plug in to make this 0. 1 is always positive. And remember, square root of something is always positive if there's no negative out in front of the square root. So we will only ever get positives to divide out of this fraction, which means that the range is only 0 to infinity. Just the positives, not including 0. All right, so what if it's negative 1 over the square root? the domain doesn't change. It's still true that x plus 6 has to stay greater than 0, x greater than negative 6, negative 6 to infinity. How does that change the range? Now you have negative 1 over a square root. Negative 1 is always negative. The square root is still always positive, but that will always divide out to a negative. So now the range values are going to be negative infinity to 0 without including 0. Okay, what about some quadratics? So I won't give you quadratics where you have to use the vertex formula. That's chapter 2 stuff. We will get there later. I do expect you to know, even though we haven't graphed transformations yet, that x squared plus 8 is a parabola that's been shifted up 8 units. Okay, so what is the domain? All real numbers. You can use R for all real numbers. What is the range? Vertex to infinity. 8 to infinity. 8 is included because that is the lowest point on the graph. It's the absolute minimum. What if we put the square root over our x squared plus 8? What does that change? So domain says x squared plus 8 needs to stay greater than or equal to 0. Well, this is always true, right? X squared is always positive. Add 8 to a positive number, it'll stay positive. So our domain is all real numbers. If you're not sure on that, if you start solving for x squared, if you think about square rooting here, you're going to get an imaginary number. So that's also your hint that there are no restrictions on x. This is one where the range is a little bit weird. I think we had one like this. I know we had stuff like this in our packet and also on our homework quiz. So the range is not all real numbers. And it's not 0 to infinity because remember, this x squared plus 8 never actually hits 0. The lowest number it hits is when x is 0, you get square root of 8, which I'll simplify in a minute. But then anything you plug in after that, you're going to get a slightly higher number, right? If you plug in 1, you'll get square root of 9, etc. So it's just going to keep going up, right? So the lowest number in the range is, instead of radical 8, to radical 2, and the highest it goes is infinity. All right, and then for 28, I've switched this to 8 minus x squared, so let's draw that graph. A negative x squared is a parabola that opens down. The 8 still shifts the graph up 8, but now it opens down. So the vertex is still at 0, 8. The domain is all real numbers. You can plug anything you want into a quadratic. And the range is negative infinity up to and including 8. All right. And last scenario, let's not forget about cube roots. So h of x is cube root of 10 minus x. Remember, odd roots do not have the stipulation of needing to be greater than or equal to 0 underneath. You can odd root a negative number, you can odd root a positive number, and you can odd root 0. So the domain is all real numbers. The range is also all real numbers. If I plug in 5 for x, I get 0. If I plug in huge numbers for x, I get negatives. If I plug in negative numbers for x, I get positives. So the range is all reals as well. Okay. Sorry, it's going to bug me. Okay. The domain for the next one, now I put the expression underneath a square root. So we're back to saying now for domain, 10 minus 2x, because it's under an even root, has to stay greater than or equal to 0. You can add 2x to the other side. 5 is greater than or equal to x, which really means x is less than or equal to 5. Whether or not you spin that around, make sure your interval notation is correct. That's negative infinity to 5, including 5. What about the range? This is the square root of something linear. If you want to think about the graph, let's see, I think it's shifted. think it's something like that, right? But you don't have to think about the graph. It's the square root of something linear, 0 to infinity. Plug in numbers. This is one that you're allowed to just plug in numbers. Plug in 5, get 0. Plug in 4, because we're going left. You'll get something, plug in 4, and you'll get something other than 0, right? If you plug in 4, you get square root of 2. That's a bit higher. If you plug in 3, you get the square root of 6, right? So you can keep going and realize like, oh yeah, the numbers are just going up. Okay. 31. Now we're back to a cube root. So it's not really the cube root that has any role in the domain. It's the fact that there's a 10 minus 2x in a denominator, which cannot equal 0. So I'm not saying greater than 0 or greater than or equal to 0. It's a cube root. So whether or not that cube root is there doesn't matter. It's the 10 minus 2x. 10 can't equal 2x. 5 can't equal x. That domain is negative infinity to 5, 5 to infinity. What about the range for this? 3 over a cube root. 3 is always positive. Cube root of something linear can be positive or negative. So we will get positives or negatives out of this depending on what we plug in. So negative infinity to 0, 0 to infinity. Forgot to say this. Y can't be 0 because there's no x up here. It's just 3. All right. We need a graphing calculator for this section. All of this was non-calc, by the way. And our quiz will similarly be mostly non-calc with just a couple of calculator questions. You need to know about regression, how to get a linear model, and how to graph something and fit it to this window. Okay, so the table shows the total enterprise values, which is V, in billions of dollars for the Golden State Warriors from 2013 to 2018. Let T equal 13 represent the year 2013. So when we type these in, we are not typing in 2013, 2014. We're just typing in the numbers 13 through 18. Okay, and then here are the numbers in billions of dollars. So how do we do this again? We go to, let me split screen here. We press Stat, Edit, clear out your old lists, go to the top, press Clear, press Enter, top, clear, Enter. What if you deleted by accident? What if I delete? I'm like, oh gosh, whoops. What do? I go to Stat, Setup Editor, Enter, and then go back to Stat Edit, and they're magically back. Okay, so make sure you have L1 and L2. Type in the numbers like a spreadsheet. Type in the number and press Enter. If you want more practice on this, go back and do the bookwork that we had over linear models. And it's just a matter of typing in the keystrokes a few times and you'll pick it up. You don't need all the extra zeros that it extended out for the decimal points. Okay, make sure you have everything typed in correctly. To be able to see the scatter plot, we need to turn our scatter plot on. So second y equals on. Make sure the first type of graph is highlighted, scatter plot. And then zoom stat, because we want the window to show what we have in our stat menu. So zoom 9. There it is. Looks roughly linear. Maybe there's a bit of a curve. I don't know. The first question says, it's not going to let me click on it. There we go. The first question says, use linear regression to create a model for this data. Rounding to 3 decimal places, write the model below. Okay, so I want the line of best fit for this data. Stat, calc, option 8, linear regression. Should say L1 and L2. If you want to see the line on your graph you can do this, store the regression equation. It's just not going to change your answers for what you're writing below, but I'll just remind you of this. Alpha trace y1. Calculate. Let's write this down. Remember, we're not going to use, this says y equals a plus bx. We're supposed to be v instead of y. V equals negative 6.658 plus 0.539. Instead of x, let's use t. Okay? And maybe instead of v, I'll write v of t. This is a function. Nothing asks about correlation. I won't ask you about correlation on Friday, but this is a high correlation, which means it's a pretty strong model. If you want to look at the graph, that line has the points fitting pretty close to it, right? Some above, some below. They're all pretty close. We don't have any points way out here. Okay. Interpret the slope of the model. So here's the slope. Remember, we have a script for this. On average, what does y represent? Total enterprise value. The total enterprise value increased by $0.539 billion. So $500 million-ish dollars per year. It's important to have that. $1 billion per year, not just $1 billion in general, from 2013 to 2018. That slope is not the same slope you get if you just do average rate of change between this number and this number. If you look at our graph, this line does not go through the first and the last point. It's a line of best fit. Slightly different. Okay, anyway. Use the linear model found in part A to predict the total enterprise value in 2023. So remember, you're not typing in 2023 into the equation. T is 13 when the year is 2013. That means that T is years after 2000. So we're going to use T equals 23 and find V of 23. Okay, you can plug 23 into your rounded equation. There's also a shortcut on your home screen. You can say, what's y1 of 23? And it'll tell you, as long as you've had the equation in y1, right? Okay, so 5.745 billion dollars. That's quite a jump. Do we know if that's accurate? We don't know, because this model is only accurate for this set of years. Okay, last question. This is like what we had in our AP question or in our notes packet. During a 24-hour period, the temperature in degrees Fahrenheit of a certain city can be approximated by this model, T of X. On the domain 0 to 24, where X equals 0 corresponds to 6 a.m. Approximate the maximum temperature during this time period. When it says maximum, it's talking about absolute maximum, which will probably equate to a relative maximum. We'll just have to see. So go to y equals, turn off the plot by just pressing enter and unhighlighting it. Clear out your old equation. Type in this one. Remember, we can't, well, I guess it has x. If it has a different variable than x, you just need to type in x. If you don't get the same graph I do, make sure that you have typed things in correctly. Okay, remember how we have to do this. We will do this a lot for our AP exam and throughout the year, so this is one to know. You type in the equation, you go to Window and set the domain. The domain is 0 for the x-min, 24 for the x-max. Counting by ones is fine. Don't change anything else. Go to Zoom, Fit, which is option 0. You can just press 0, but I'm just showing you where it is. Zoom Fit makes it so that the X values stay on 0 to 24. Oh, wait. Did I do 24? Yeah, I did. The X values stay from 0 to 24, and you can see it adjusted Y values for us. What's the maximum temperature? That point right there. So go to second, trace, maximum. Left bound means move your cursor to the left. Mine takes forever. Past the maximum to the left, press enter. Right bound, move your cursor to the right, past the maximum, press enter. Guess, you really should say calculate, enter. And it tells me, I don't see the cursor, but it tells me what the point is. Approximate the maximum temperature. Which one of those numbers is the temperature? Remember, X is the time, Y in this case, T is the temperature. So 63.928, about 63.928 degrees Fahrenheit is the max temperature. All right, that's it for this review. Feel free to go back and look at the AP Classroom problems. I've got the paper versions on Schoology. Go back and kind of look through the notes packet, skim through your homework assignments. If you want even more practice, take a look at any of the homework pages. I don't have the actual ones, but take a look at the homework pages and do problems in between the ones we did. I just didn't pick every problem because I didn't want your homework to take a million years. So anyway, there's lots of chances to do more practice. Let me know if you need help.